All right, here's try it 2.7 for pre-calculus OpenStax. I'm doing this problem even though it kind of makes me cringe because it's asking you to do something using an inefficient way. It's kind of a stupid way to graph function. I shouldn't say stupid. To graph linear functions, there's lots of ways you can do it. Probably the least efficient way is this idea of just plotting points. And plotting points, all you do is throw a couple numbers into the function, your choice, whatever the hell you want. I like to throw in easy numbers, like, I don't know, 0 maybe. If you throw 0 into this machine, you'd say, well, I got negative 3/4 times 0 plus 6, but negative 3/4 times 0 is 0, and 0 plus 6 is 6. So when I put 0 into this thing, 6 comes out. What if I put, I don't know, 1 maybe into this machine? Well, then I get negative 3/4 times 1 plus 6. Negative 3/4 times 1 is negative 3/4. And if you add 6 to that, you get, 5 1/4? Which I don't really like decimals, but for the case, for this example, I'm going to go ahead and use decimals and call that 5.25. Really, that's plenty. That's all you need. When you're trying to graph a linear function, you only need 2 points. There's 2. I'll do another one just because. I guess this would work as a check if you felt like it. You can throw a 2 into this function and go through those steps. If I sound bored, it's because I am. Negative 3/4 times 2. I don't know. If you owed somebody 75 cents and then you doubled your debt, you'd owe $1.50, so it's negative 1.5. That's weird. And then add 6, and you get 4.5. And you know what? I'm going to do another point. I'm really beating the hell out of this thing. But I'm going to go ahead and throw 4 into this function, and the reason why is negative 3/4 times 4 is pretty easy to do. You can think about this as 4 over 1, and this 4 in the numerator and this 4 in the denominator cancel. So this whole thing turns into negative 3, and negative 3 plus 6 is positive 3. Way more than I need. I only needed 2 points, but I got 4. And now I'm going to plot those points. When x equals 0, y equals 6. I'm going to use this graph up here because I don't want to try to draw my own. X equals 0, y equals 6. That's this point right here. X equals 1, y equals 5.25. I don't know, somewhere in there. X equals 2, y equals 4.5. Somewhere in here. X equals 4, y equals 3. Right there. If I did things right, these should all fall in a straight line. They do appear to fall in a straight line, so connect them with a straight line. Ooh, that's not the straightest line in the world, but it's good at well, okay, it's close. Okay, I'm wasting your time, wasting my time. Stop this video here. Put yourself out of mid. Connect those with the straight line. The issue I had with the one before is that line is not parallel to this line, and the way I drew it, I kind of made it look like it was parallel. The one that I'm drawing should be a little bit steeper than the one that's shown there. So I don't know, maybe that's better. Before I call this good, I'm going to go ahead and kind of spoiler alert. There's a much, much, much better way to do this problem. Rather than plotting points, this is in slope-intercept form. This is your y-intercept, this is your slope. So start by plotting your y-intercept. Start by putting a point on the y-axis with a height of 6. Hey, there it is right here. Now if I had one other point, I'd be done. And you can get one other point by using the slope. The slope of negative 3/4, you can think about it as negative 3 divided by 4. Note that this fraction with the negative out in front is equal to this. And if you think about this as rise over run, I'm going to go up by negative 3, aka down 3. 1, 2, 3. Down 3 from this point right here. 1, 2, 3. And then I'm going to go to the right by 4. 1, 2, 3, 4. That gives me this dot. If I just had this dot and this dot, not these ones in between, I could still connect them with a straight line, and I'd still come up with the exact same answer. That would not be by plotting points. It would be by using the slope and the y-intercept, which would be much more efficient. You'll get to that later in this chapter.